Hey guys, today we can talking about pasteurization. Let me see the name. Pasteurization of milk. Pasteurization of milk started, you remember in the previous lesson, we were talking about Laval and Tetra Pak and a company that interesting and working in this field of in the dairy production, dairy equipment and the dairy processing. Laval, as I mentioned before in the previous lesson, interested in milking and collection. Now we should talking about reception, pasteurization. Reception, after collecting the milk from farm, we should we should transfer this milk to reception to make a pasteurization. We can say pre-pasteurization for this milk to keep it safe. Then doing pasteurization for production. Okay, see here, D-Laval, a company for milking and collection. This processing solution, a lot of companies like Tetra Pak, like Gia, like SPX, like a lot of companies, maybe Cronus, I don't know, KHS, working in this field to process in this blue part. Also, blue part here, this reception, pasteurization, and this products, pasteurized milk, cream, fermented product, ESL milk, as mentioned before, extend shelf life milk. I mean, more than 4 months or 3 months, maybe. UHT milk, it's mean ultra heat treatment or heat temperature. High temperature, sorry, ultra high temperature or ultra heat treatment milk. The expire of this milk 6 months. Ice cream, cheese. Okay. Packaging solution, we have this package from Tetra Pak. Also, we have a lot of products and produced by another companies. Milk reception. See here. This milk reception. We transfer the milk from farm to reception area by this tank, okay? This tank covered by a double jacket to keep the product in the temperature, maybe as I mentioned before, 4 degree to keep it safe, not contaminated from anything, and can connect this pipe to here and doing the process and to transfer the product from this tank to tanks of reception area. This we can say the new technique, or we can say the new technology. Now this the old technology. No need to use this. Milk reception, as mentioned here, milk reception. This tank connected to this flow plate, connected to this pipe. Coming to diameter, I will talk about this and explain about this again, sorry, later. Let's take all the air or foam or undesired foam, undesired perfume, or we can say smell from milk to take it to extract it from this milk out. Okay, then pump, filter, flow meter, as you know, going to cooling and storage tank. Cooling, double check a tank or plate heat exchanger or tubular heat exchanger. Now we're talking about important part of this lesson, of this process in the reception area, clarification of milk. Raw milk. Raw milk, you know what the meaning of raw milk? The milk which coming from cow farm. Raw milk may contain impurities such as cow hair, manure, parts of plants, sand, and dust. We need to to, we can say, clarify this milk from this impurities. How can we do that? We will explain later. You see here the raw milk coming from farm. The farm, as we mentioned before, we have a lot of things here, like plants, like dust, like impurities. So we need to clarify this milk from this. How can we do that? Here. Why clarification of milk? Bacteria and cells to ensure that lumps containing bacteria doesn't pass through the pasteurizer or UHT plant. A risk that heat treatment does not penetrate all bacteria. Some bacteria reduction is achieved. Large part of somatic cells are removed. All these points achieved by clarification of the milk. Okay, this clarification equipment, clarifier, its name like clarifier. See here, let me do it small. Let me zoom out. See here, this milk coming from this inlet and going to this vessel. This vessel we can say this vessel block, we can say closed vessel contained inside it connected to some of a plate, or we can say what the name of this, like a plate, knife, like plate, like cylinder plate, like I don't like cylinder, like circle plate connected here to ensure to us how to clarify this milk. You see here the milk coming here and going from here, then going inside, we can say inward the shift to go out here. And we see this impurities which we don't want them, like dust, like dirty, like bacteria. We need to we need them to be extracted from the milk here. This happened by the centrifuge. You can say the centrifuge rotation of this shift with this plate. Okay, so all milk after clarifying from this impurities, the milk will going up and going out to be to a tank or another process. Next process, common analysis performed at milk reception. See the common analysis performed in this milk: fat content, protein, somatic. You see this. All of this should be done by the lab team to make sure that the milk is okay for production. See this, the analysis method, fat content. We can do it by these devices like this. Name of this, you can find them. You can research or search for them by Google. You can find them by Google, any website. You can find them and see how we can test fat content of milk by this device. Fat analysis, this is the process or the way how to test. Analysis method, protein, we can do that by this devices. See, like this, phos, glucosan, lactose, protein by this, lactose by this. We can say this lab devices, we should buy them and install them in our lab of reception area. The way how to test antibiotics by this way, Dilvo test kit. This Dilvo test kits as process mission here. We can looking for this or researching for this by Google, searching for this by Google. Alcohol stability. All of them fat, We can say fat, protein, alcohol stability, another thing as mentioned. This should be done by lab team to make sure that the product or the milk is ready or okay for doing our production process. Common analysis performed at milk reception. Freezing point. This is so important. Freezing point. We should do it by this device. Why it's so important? We need it when we produce a meal, when we produce ice cream or cream. This is so important for us. We will explain about this in the next lessons. At the dairy, what the meaning of the at the dairy? We was talking about reception area. Now we're talking about at dairy. What the meaning of dairy? I mean at the at the plant which will help us to doing pasteurization or processing solution inside the factory or inside the company which produce a milk or cheese or another product like this. Pasteurization. Now we're talking about pasteurization. Pasteurization. All of us know what the meaning of pasteurization. Milk pasteurizer. This milk pasteurizer. Milk pasteurizer. Firstly, consists of balance tank, BTD or balance tank. After that, pumps, pipe going to plate heat exchanger, or sometimes we use tubular heat exchanger. This PHE, plate heat exchanger. Going back from plate heat exchanger for some, we can say primary heating temperature, almost from 30 degree, from 25 degree till 40. Then coming back to separation. Separation, it's like clarifier, like clarifier, but it's different because it's separate between to separate the whole milk or raw milk to two parts, skimmed milk and fat. See here, skimmed milk going directly to heat exchanger or complete and mix with a fat as we want, as the standard we want. The fat going to this equipment which named as or known as standardization, which standard the milk for the customer or for the consumer as he want. See here, standardized cream which coming out, and some of this cream depending on the control system here will mix again with skimmed milk and going here to plate heat exchanger to complete our pasteurization process. Okay, going here after standardization and after separation, we will get standardization. After standardization, we will go to heat exchanger. Then going to homogenizer, we will talk about homogenizer. Then going to tank. Then going to standardized milk, which we will need it for production. See here, power of separation. Now we will talk about this separation. Power of separation, see 1 giga, 5 giga, 5,000. Sorry, not 1G, 5G, 5,000 G. Let's see what this meaning. Separation. Now we're talking about separation. Separation in the, you can say it's equipment like clarification, but different in the process. See here, the cream, the cream example, the fat globules has a lower density than the skim milk and therefore moves inward. See here, the milk, whole milk or raw milk coming here and separated here. The density of fat will, it's lower than the skimmed milk, so it will go we can say inward. It will move inward the equipment, inward the separator. So going in this line, and the skimmed milk will go outward because it's high density, then going to the line of skimmed milk. Here, see, we have here can say service kit and some gaskets, some O-rings to keep this product separated good, not mixing again or not anything happen. See here, let's see complete. The skimmed milk moves outward. Skimming efficiency. Depending the skimming efficiency of this equipment, of this, what we can find or what we can get from this equipment. I mean, this equipment separation equipment or separator, we can say. We will get the skimming if skimming. The skimming meaning separating the milk, skimmed milk, and the fat. Skimming efficiency. Skimming efficiency depending on design of separator, the rate at which the milk flow through. I mean the flow here, flow of product, which coming in to this equipment. The size of the distribution of the fat, the size of the distribution of the fat globules, normally 0.04 till 0.07. Here, what this meaning? The size of the distribution of the fat globules, what we want to get after this separation. I mean, and what we want, what is the product which coming inside it? It's fully what the type of milk coming from buffalo, coming from cow, coming from sheep, coming from cow, any animal. So we will design this separator depending on our product. What this meaning size? All products I have already mentioned. I mean, the fat of cow is different from buffalo. The fat of the cow milk, the fat of buffalo milk different. And for can say you understand me what I meaning. So this size of distribution. How can we distribute or the design of this equipment? Design it depending on our requirement and our inputs. Centrifuge models. Clarifier, as we mentioned before, this for cleaning, this for clarify the milk after farm at the reception from any impurity, from any bacteria, from any dust, from any sand, anything coming with the milk from the farm. But this no, this will separate the fat and the skimming milk. See, they are different, little different. We have here one outlet, we have here two outlets, see? And we have here panel to control this. The purpose of this panel and HMI and control system inside this panel to control the percentage of fat we want to skim it for to be skimmed from extracted from this milk or this product. See this old virgin separator, old virgin separator, cream, milk, skimmed milk. Parameters affected separation. Particle size, density difference, viscosity, centrifuge, radius, centrifuge radius, viscosity, viscosity of product, I mean viscosity of milk, is different depending on the milk which coming from any animal, buffalo, cow, anything. Centrifuge radius, design of the inner side of not clarifier, of separator. Centrifuge speed, particle side. Okay. Density of milk constituent. It consists of the density consists of milk plasma, milk fat depending on temperature. See here. Casein, micelles, casein, micelles, yeah, micelles, bacteria spore. Principles of milk separation. Whole milk, raw milk, coming in this percentage. Okay, this we can say this milk, this water with something we can say some protein, some casein, some sugar, some another anything. We can say this water mixing with some things, with not important things we can talking about now. We're talking about separation. So later we will explain about this. Now, separation of principles of milk separation, starting with whole milk, water, SNF, this solid nature fat, maybe, yeah. And this fat, 4 percentage, 8.9 percentage, and the other water. 100 percentage coming here, then going fat, 10 percentage, 90 skimmed milk. See here, in skimmed milk, we still have this fat percentage, but here 40% of fat and SNF 5.7. Here SNF 9.7 after separation. We can go to next. It's clear, I see. Then concentration of cream. Concentration of creams depending on the percentage of fat here. After we can say after separation, after standardization, depending on the distance, we can say depending on the percentage of milk. Here, distance between fat globules in milk and the cream at different fat content. See here, 4 percentage, like this distance. 20 close, 40 close more. Here, 72, here almost fat. We can test this by lab, or we can test it by color, or by shape, or by texture, or by taste, depending on the way we test it. Milk pasteurizer. Milk pasteurizer, as we mentioned, raw milk coming here and going to pasteurizer, as mentioned before. Now, I think he will talking about homogenizer. Oh, still we're talking about standardization of consumption milk. See here, after separator, whole milk separator to fat and skimmed milk, we have part named as we have device standardized the fat as we want, as the we can say as the consumer want. For example, as mentioned before, some consumer want, we can say the consumer or market want the percentage of milk 4%, for example, 0.1. Yeah, as depending on the market you have. So for doing that, we have this equipment. This equipment taking the fat here and depending on control system which control these valves and the flow meters and pumps, valves and flow meter to inject or mix the milk, mix the fat again to skimmed milk, depending on the percentage which controlled by this panel. I mean control panel to give us standardized milk. Standardized milk. Here, standardized cream. We have two outlets. Standardized milk, which means skimmed milk mixed with fat. Standardized cream, it's only fat. Okay. Tetra Pak, this company which manufacturing this equipment as standardization equipment for milk standardization equipment. Tetra Pak and Fast named. See here, milk standardization in the market or for or as demanded by consumer. It will be like this color: milk 0.1 fat, this color; milk 0.5, this color, and the others. Okay. So I see it's clear to understand what I was meaning here. This control valves and this equipment we can say component controlling by this panel to give us the percentage of fat to be mixed with this skimmed milk to give us the milk standardization or milk. We can say the milk bucket as the percentage of fat we need to, or the customer or consumer want. Milk pasteurizer. See here. After this, we see here separator, separator, standardization system here. Then going to plate heat exchanger. After plate heat exchanger, coming to homogenizer. Let's see the homogenizer. What is homogenizer? The milk pasteurizer. This homogenizer. See? What is homogenizer? Homogenizer. What is homogenization? Before homogenization, after we can say standardization, the milk with the fat, we will see, and we can say we will see in the microscope the fat distribute in this shape. It's not acceptable for production. Now, we need it to be like this, separated, and we can say reduces the size like this. So this meaning homogenization. Homogenization, it's the process to we can say to break the fatty globules, these fatty globules, to this shape. I mean to small size. Reduce the size of fatty globules to this size and evenly. What the meaning of evenly? One equal to others, like this, equally or evenly. See here, why homogenize? Improving of product quality of dairy, beverage, ice cream, and prepared food. Not only for milk, beverage and ice cream and prepared food. This homogenization will improve. Reduce the size of fat globules of or particles or disperse them evenly, as mentioned before, to give us improved product. See here, Stokes relation. This relation show us the viscosity. We can say the velocity of we can say the velocity of rising the globule or the size of globules during depending on the time. See here, 0, 1, 4, 8 weeks, and this globule size. The globule size, this one here, 3.2 micrometer. See here, and this size 0.8 and this size 0.2. During the time, see here, after 1 week, you will see the globules will be bigger. You can understand that. And this relation, maybe we will use it to identify or to check the time we need to save or stock this product in our storage or in our market, or depending on what we save it or store it. Working principle of homogenizer. This equipment named as homogenizer. See here, this main drive motor and main drive connected to like engine of as I see it's like engine of car, but not depending this working by this drive, AC drive or motor or anything you say. Then running, pushing this shift, 3 shift or 5 shift, depending on what you want. Here 4 shift or five maybe. 5, yeah. One of the 4 here and 5 here. 4, 5 shift to give us to work like pump to vacuum this product from this pipe, from this line, to vacuum here and push it inward the homogenizing device. We can say like a vessel or like a small room have a homogenizing device like piston pushing by hydraulic to make high pressure here, to give us high pressure almost to not 3 to 200 till 250 bar, to give to we can say to break the fat globules to small size. Okay, I will show you here in the next. Big becomes small. Reduce the size of the globules particles. Spare them evenly for liquid and viscous products. See here? Let me show you. Good. Oh, sorry. See here? The product coming from the inlet 3.5 micrometer. See here? And by this disc, which pushed by homogenizing device to make this gap. See here, the gap is approximately 100 micrometer. This done by this disc of shift, as we mentioned here, as I mentioned here, this device, homogenizing device. When we get this 100 micrometer with high pressure coming by drive, I mean here, by this drives, we will get high pressure depending on the gap we have get by this pressure, by hydraulic pressure. We will get this gap to break or to reduce the size of this globule like this. See here, surface layer of homogenized fat globule. This fat and this surface layer after homogenizer. Partial homogenization. What this meaning? To reduce investment cost and reduce the energy and water cost and reduce cost for spare parts, we can use this partial homogenizer. See here? But for full stream homogenizing, we will use this. The comparison between them, this high flow, I mean high production efficiency, and this low flow, depending on the investment cost, depending on your project. Fat global distribution, yellow UHT, red pasteurized milk, unhomogenized. See here unhomogenized, fat global diameter from 0 to 10, and the volume per micrometer. The good, sorry, as we see here, on homogenized milk, we cannot have a volume, but we have a high volume at UHT milk. Pasteurized milk, here our process. For UHT, we should get this volume. For homogenizer, we should get to this. Milk pasteurization. Let me say goodbye today because I see it's enough today. Let's talking about pasteurization later. Okay. Thank you for your following and watching this movie.